I'm actually really looking forward to this session. Not only do I get to talk about one of the things I'm really passionate about, which is the transformation of our industry and the continued and potentially dramatic improvement in terms of its sustainability. But also, I'm really looking forward to some of the questions afterwards. So please feel free to ask any questions that you think are important to you or might be interesting to others. So, as has been alluded, I've worked in the industry now for about 30 years, and the mining industry is an industry that I'm really passionate about. And over that 30 years, there's been, I think, tremendous change. If I reflect back in terms of our ability to deal with and protect the environment around us. If I look at our productivity, again, in gold mining terms, I remember when somewhere between 2 and 5 grams a tonne for a big open cut mine might have been a cut-off grade. Now I notice that we get down to 0.4, 0.5, still able to do that economically. We've seen similar trends in copper, we've seen similar trends in nickel. From a safety perspective, huge changes in those 30 years. I still remember when, sadly, we used to measure fatality stats. Then we moved to LTI, now we moved to all injury. I think we've made quite amazing changes. I think one of the challenges, though, for us as an industry is that no matter how much we have changed and no matter how fast we are changing, the opinions and the thoughts of society are changing faster. So, that is why, it leads to criticism of our industry and in many cases protests, in other cases, young people just not wanting to enter into our industry. So I think one of the biggest challenges we have in the mining industry today is to change and to shape the opinions and the expectation of society, of people and of citizens. And I think that's a huge challenge, especially given that most people don't have a good understanding of our industry. It's not an industry that they interact with. When they do interact with it, it's unfortunately for, very negative reasons. We've blown up a 46,000-year-old cave, or a dam has just been released and tragically killed people or demolished. And, we're not the only ones having that challenge. One of the things I notice with young people is sometimes, even understanding where, milk and eggs, some of us don't even really understand where peanuts come from, let alone something as abstract as mining. So I think giving people a really good understanding of how mining affects their daily life, how their daily life is reliant on mining, is becoming more and more important. And I think, there are other industries that we can look to that have really done a spectacular job with this. I think, agriculture, to name one, and some of the focus on protein, etc., has been really attracting and exciting young people. And you might say, well, and in fact there is, I think a growing demand for our products. So it's not as though, we're not influential in the lives of society and the lives of people. One of the interesting factors, though, is that over the last few years, the rate of metals consumption has declined as a percentage of GDP. And really that's reflecting an increase in services. And again, what most people are interacting with are some of those services industries. I think one of the things that COVID has done is re-emphasised the importance of mining in many of our societies. If I look at what's happened over the last sort of 6 months, in many, many countries, mining has been regarded as a critical industry, not only to fuel GDP as services has shrunk during lockdowns and other changes to the way we've been able to run our economies, but also fueling, again, that much needed trade to allow governments to then invest in medical, in unemployment benefits and other parts of our societies that have required that distribution. And also to fuel some of the requirements for infrastructure as we start coming out of this COVID time. And I know, a lot of people might ask, well, why is it so important that we start changing the opinions and expectations of society, of people, of citizens, of those around us? And I think there are three reasons. One, we've seen huge changes in investors, with ESG becoming significantly more important, not just for what we used to consider to be fringe investors, those that were, very niche, very specific, but even mainstream investors now really looking at how each mining company is dealing with various aspects of ESG. I think the positive side of that is it's putting a greater emphasis, therefore, on innovation. I know one of the questions that I often get asked, either when I was Chief Innovation Officer of Barrick or now as the CEO of Geovia, when I talk to investors, is not only, how can they understand who will win out of some of these investment strategies, but they're fundamentally interested in how we're using innovation, how we're investing in innovation in order to drive greater sustainability. And I think the three pillars of sustainability in that sense: how we're doing in terms of driving productivity and profitability, how we're protecting the planet and thinking about environment, and how we're working with our people to not only drive better outcomes for them, but also for citizens, for communities, for governments. I think the second component is definitely around our workforce and the workforce of the future. I think, and certainly if you look at some of the statistics, in the next 10 years, the mining industry is going to need to attract around about 80,000 people worldwide, or certainly in the major mining centres. Canada, for example, loses around about 5,000 people. 80,000 people is in Australia. 5,000 people per year. We're losing people out of the mining industry. Russia, for example, around about 50% of the people working in the mining industry will retire over the next 1 to 1.5 decades. So we have this real need to start attracting more talent into the industry. And a lot of that talent at the moment is still reticent about our industry. Either they think of us as dinosaurs, they think of us as uncaring profiteers, or they think of us as not having interesting problems to solve. And one of the things that technology can do for us is to be more attractive for those young people and attract them into our industry. And I noticed one of the things, both for Rio Tinto and BHP, when I was talking to them recently with their IROCs, one of the things that their IROCs have enabled them to do is to dramatically increase the diversity of their workforce. So, prior to IROC, those roles that were distributed throughout their business would have had a very similar demographic to the average mining industry. So 17% women, mainly people focused on technical and engineering type roles, tradespeople. It would have been very similar demographics to those, experienced in the rest of the industry for that particular location. However, what they're experiencing in the IROCs is around about 50% women. They're seeing, people coming from all sorts of different industries. So they've got doctors, they have paramedics, they have traditional people from mining, they've got people from the airline industry, they've got people from transport. So, agriculture, a great range of people. And similarly are able to introduce people to the industry that previously wouldn't have seen our industry as a choice for all sorts of different circumstantial reasons. So this challenge that we have today, I think there are plenty of opportunities for us to rise to this challenge. And I think the one fantastic asset that we have is that we have these technologies that are emerging that are absolutely mainstream, that have been seen that we can then now use to solve some of these challenges that we have, become more attractive as an industry to investors, to the younger generation, and to communities and governments, and be an attractive organisation that they want to have in their backyard. I think in order to do this, there are 4 system level innovations that we really need to solve as an industry. And they are global ore body intelligence. So we need to really understand our ore bodies. And, you know, if we could imagine a world where we could understand our ore body down to the last gram, so we know where every gram of that ore body is. Not only can we avoid some of the challenges that we already have in terms of, you know, accidentally putting a process plant on top of our ore body, punching a shaft through it, or, you know, heading left when we thought we were going to head right, or, you know, should have headed right. But the other thing that we can do, if we absolutely understand our ore bodies, is take a lot of the noise out of the system that is our industry. You know, one of the things I often get pushback from, you know, as I talk about how we can bring fantastic capabilities from other industries into the mining industry. So often I talk about the aviation industry, for example, where, you know, we can now design an aircraft in the virtual world. We can fly it for 1 million man hours. We can do that collaboratively using engineers, using you know, technicians, using people from all over the world simultaneously to help design that aircraft. We can then run it in simulation and understand how it's going to perform from a fuel perspective, you know, how it might land on different runways. We can simulate all of that in the virtual world. And not only does that allow us to shorten the time that it takes to get government approvals, not only can it reduce the cost, because, you know, we're no longer building 10 planes, flying them, realising that 8 of them, you know, aren't economic, looking at the 2, refining the 1, and spending all of that time, and frankly putting, you know, potentially pilots at risk and others who are doing some of this test flying. But, you know, we can also, so we've significantly saved money, significantly reduced time, but also increase the talent pool of people that worldwide can work on that particular problem. You know, and often I talk to people in industry and say, this capability, it's available now in other industries. So imagine if we applied that to our industry. And one of the pushbacks often is, yeah, but aviation, car manufacturing, that's all known. It's relatively known. And the pushback that I have is that, you know, if we take the car industry, 15 years ago, they also had as much chaos in their production process as we do, in terms of planning, in terms of knowing what customers want. Their unknowable was the customer, was that end. Our unknowable is the geological end. But they've spent a lot of effort, not only refining their workflows, integrating their information, integrating their silos, understanding what the customer wants, to the point now where the car industry actually can online allow you to design your own car. Yes, okay, this is a small part of the industry. Again, this capability is available. So you can design the car down to every last feature that you may wish, and they can then produce that. So very personalised production. And even in the more mass market, you know, if you sit at Toyota, no 2 cars in that assembly line are identical. Yet they can deal with that level of uncertainty and that level of change because of the way they've integrated their processes. So I think we can apply some of those same learnings around what if we spent a lot of effort really understanding our geology, really understanding, using quantum mechanics, using AI, using integrated techniques and systemic techniques in order to, and sensor techniques, etc., to significantly understand our geology. The second fundamental problem that we need to solve is how do we automate and electrify? And again, I think the wonderful thing about the world that we are in currently is electrification and taking us off diesel is very much within our planning horizons. You know, I think the cost of a lot of those solutions have come down dramatically. We're starting to see more and more battery electric vehicles being created and other options. There's conveyance technology. So the electrified mine, not only are there examples, yes, they tend to be the smaller operations, but we're starting to even see some of the larger operations significantly create, whether it's electrification, whether it's hydrogen technologies. But this issue of coming off diesel and electrifying is starting to become absolutely a reality and a problem that we should be solving. Automation, we've seen leaps and bounds, especially here in Australia, which is fantastic with automation, though Canada may steal our cap in terms of the most automated mining industry. They've got two very large implementations, one in oil sands that has already started, one in copper and coal that's about to start if it hasn't already started. But not just around automation of the trucks. How do we automate a number of the processes? And there's, again, some great technology appearing in robotics, which allows to automate maintenance, even automate some of the processing, look at automating fundamentally different parts of the value chain. Some great things coming out of Chile in terms of automated blasting, even automated tie-ins, both for underground and for open cut. And then here I also know other development happening in some of those sort of areas. The third problem that I think we need to really be focusing on is this idea of precision extraction. You know, how do we just take the metal that we're interested in, the mineral that we're interested in, and again, some really interesting technology. I was recently talking to the CEO of an organisation who has basically using AI and sensor-guided drilling or boring technology in order to try to follow narrow veins and just extract the vein and leave the rest of the ore body behind. Still in startup sort of mode, but potentially got some really great ideas. And of course, there's examples of us looking at things such as in situ extraction techniques. And then the fourth one, which I think is as important, but I don't see quite the same level of focus, though there are some a couple of organisations, especially coming out of Canada at the moment, looking at this, which is how do we create symbiotic development? How do mining companies, governments and communities fundamentally develop a much more symbiotic relationship? How do we rethink the way that we generate and distribute wealth as mining companies, as governments, and how do communities benefit from that? And it doesn't necessarily have to just be financial wealth, but also this wealth of knowledge, this wealth of access to technologies. How do we bring those to our communities for the betterment of the community and the development of industry within those communities? For example, automation or AI that we're using to understand weather patterns, etc. I think if we could solve those four fundamental problems, and a lot of that technology is available, then we would be significantly different in terms of our sustainability, both in terms of how we impact the planet. I mean, certainly a significantly smaller footprint, how we benefit people, the community and governments, and how our efficiency and how we drive profits and profitability. And I think one of the most profound components of all of that, and if you link those four system level improvements together, the focus on reducing the amount of waste at a very fundamental level that we move, it impacts the industry and our sustainability dramatically. So again, you know, if we knew that we could precisely extract that, we could automate, so we don't necessarily have to put people into the extraction process. You know, absolutely, we can have people monitoring, we can have people doing tele-remote, we can have people, you know, sending or planning and optimizing those processes. And then, you know, if we can think about, again, how that wealth is distributed, you know, whilst we may complete each mine faster, the wealth that we are generating and distributing would enable us to get to the next mine also faster. So, you know, reducing permitting time, increasing acceptance to communities, etc. And I think that, you know, there are a number of fantastic examples of people and in organisations working on this very problem. I know Chile certainly announced the prize for a zero waste mining industry. Similarly, in Canada's CMIC, looking at, again, how do you have zero waste movement, zero waste more broadly? Because waste movement is absolutely fundamentally part of it, but also the elimination of waste, downtime, redoing things, etc. As well as, you know, here in Australia, where there's a number of examples of some, I think, some great research and development going into this very same conundrum. And as I've been alluding to, you know, as we've been speaking, I think one of the fundamental ways that we will transform the industry is through the use of data, through the creation and then the use of that data. And I've seen huge leaps forward in the industry in this. You know, things that we never had digitised before, such as core, now being digitised first. Things that we never used to digitise before, such as maintenance records, now going directly into iPads. The collection of data from automated trucks or even not automated trucks, which again, we didn't used to have, now we have. And you know, en masse, I'm seeing greater communication systems or better communication systems. You know, I know there's a number of organisations, in fact one that we're working with very closely, that's dealing with computing on the edge. So not only can you have good underlying communication systems that allow for the transfer of data and information, how do you then actually transfer the least amount of data for the maximum effect? Because again, you know, data still costs to move it around, to store it, to manipulate it. Even if those costs are coming down dramatically, how do we be efficient with the way that we collect and maintain and send data? But also, how are we efficient in terms of how that data is used in the field in real time, especially for decisions that don't necessarily require human involvement or people to do something. So I think we're getting significantly better at collecting data. Still a ways to go to be fully digitised. I think one of the challenges that we have now, though, is what do we do once we have collected that data? And, you know, I speak to a lot of organisations, and in fact, even some of our early attempts in Barrick, we create these quagmires of data and information. And I know a few of my peers have recently been using the term sort of, you know, rather than a data lake, we create these data swamps or data quagmires, and various attempts to sort of reterm that. But how do we organise that data, organise that information? And again, it comes back to how much do we leave in the field and leave at the face, and how much do we bring forward? And I think this is where, as engineers, we need to be really careful, focused and thoughtful, because, you know, I think we should follow more the Formula One model, where Formula One cars have the least amount of sensors for the maximum amount of data, and then send the data in the appropriate packages. Similarly, we should do the same. But then, you know, once we have that data, and I think having databases that are not only analytical databases, but also object databases, which allow us to then simultaneously do AI and analysis and understand that two-dimensional data and information and see that in the context of three-dimensional information. I think that is a big leap forward in terms of how we use data and how we ultimately transform our industry. Because I think transformation is not, and the two steps to transformation that we've yet to really conquer, the first is to break down the silos, because we're still operating in silos, we're still collecting data in silos, we haven't yet fully integrated, and that is certainly where other industries have seen significant productivity uplift, significant safety uplift, significant transformation, is when they can break down those silos. So, you know, in the car manufacturing industry, those that understand about the customer data and those that understand about how to produce a car and those that understand how to design a car, that they all come together and are looking at the same data, see interesting insights by virtue of the fact that they're collaborating. But that integration is our next fundamental step, and genuinely valuing that integration. Because one of the challenges I have at the moment, talking with a number of different companies, is a lot of people we're accepting that we need to break down those silos, but actually valuing to take those steps forward, I think is the next challenge for us. And then the third challenge is really being serious about collaboration and wanting to work not only collaboratively across those silos and optimizing across the systems. So, you know, where we see, again, dramatic uplifts in an improvement in productivity and sustainability is when we can break down, or we can bring geological information, mining information, processing plant information, financial information, you know, maybe even commodity or sales information together to solve problems. But if we're really collaborative, then we will also fundamentally value visualization tools, value three-dimensional data, because I think the reality for most of us is moving from two-dimensional planes to three-dimensional solids is somewhat challenging. I know that there's some fantastic geologists who are really good at that, but most of us mere mortals struggle to do that. We have many people in our industry and many people in our communities who aren't used to looking even at graphs, yet, you know, we expect them to understand some of this, as I said, two-dimensional data and information. Yet everybody, all of us, when we look at a picture, when we look at something in three dimensions, you know, in the real life, we know what that is. We can talk about it. We can understand it a lot more easily. And so I think the next significant leap forward will be for us to be able to create 3D experiences, three-dimensional models, three-dimensional experiences, and allow people to engage in that experience with us. So whether it be a geologist explaining to a community member, whether it be a community member similar to what the City of Singapore has done, building a virtual twin of Singapore and allowing community members, citizens to then move within that and provide feedback on different spaces, move the buildings around and you know, see the changes and improvements and then provide more feedback. You know, if we can bring those same things into the mining industry, you know, imagine a situation where our communities and our governments can walk through the process plant, the mine that we're planning on building, or the what will be left at the end of the mine when we've done the rehabilitation. It breaks down some of those misunderstandings much more rapidly. So the real competitive advantage, in my view, for mining companies is not necessarily that they have to create these technologies, because a lot of these technologies and everything that I've spoken about is available now. The real focus for mining companies should be around, and frankly for METS companies, is speed of development of those technologies, using the customer's voice and solving customers' problems. And then for the mining companies, the competitive advantage is the speed at which they can adopt those technologies into their businesses. And not just once, you know, so not just one set of automated trucks or one mine site optimizing their strategic mine plan, but then applying that across our entire suite of mine sites. The speed at which mining companies can do that will set them aside from other mining companies, in my view. The problem, finding a technology that solves that problem, and then working with their people to get that technology implemented rapidly, get their teams to change the way they do things, to take on board that technology and then start reaping those benefits. So it's really about the speed to value for mining companies and maximising that speed to value, which is about the implementation, not just at one mine site, all the way through to those new behaviours and therefore value flowing, but across all of their mine sites. And I think those mining companies that do that the fastest will be those that will set themselves aside and be significantly more successful. Similarly with METS companies or supplying companies, those companies that can work with their customers, understand the problems that their customers are trying to solve, and then have solutions to those problems, but be able to describe it in terms that the company can understand. So what is the value to the company? What's the problem they're solving? What's the value of the solving of that problem? And then, this happens to be the technology that enables that. That speed, we also need to increase rapidly. And again, the speed to delivering that value will set supplier organisations from others, because we need to speed up our rate of change. Historically, and I think Robin Batterham often talks about this, we've roughly had a major technology change every 40 years, or it takes about 40 years for a major technology change to permeate into the mining industry. I think haul trucks, automated haul trucks, we've been doing for give or take about 15 years. So you might be able to argue we're getting a bit better. But we need to get that speed to sort of a few years, and especially when it comes to software integration, it's much easier to continue, update, refine, get those advantages than maybe it is with some of the physical technologies. And I think one of the fantastic things, and one of the things that we maybe underplay as an entire industry, is that the more we transform and the more we use technology to create those transformations, the more fundamentally that people are important. And I think again, going to the IROCs have demonstrated this really well. So one of the challenges one of the qualities that the IROC fundamentally raises is that you really want people that work well in teams. You really want people that will collaborate, because you want to now be able to make decisions rapidly. So you've now got the technology to do that. You've got the technology that will help guide people, will help augment people's decision making. But that not only puts more emphasis on the importance of having really fantastic people that can, with no ego, use some of that information that's coming in, analyse it, make a decision, and obviously the speed at which they can make that decision is important, but also that they can work with others and again value that level of collaboration. And I think this level of collaboration also is important across the whole industry. And again, people in our industry being fundamentally important and being increasingly more important as we embark upon this technology journey. The ability for us as an industry to work collaboratively on these problems, rather than constantly having to re-solve those problems, reinvent the wheel, whether that be between countries. So I know often when I was living in Canada, one of the things that I used to often do is say to the people in Canada, have you seen what's happening in Australia? Are you sure that problem hasn't already been solved? And vice versa, here in Australia, are we sure that it hasn't been solved in Chile? And again, now we have the technology that enables us to remain connected, across those countries much more rapidly, to collaborate together much more efficiently and effectively as an industry, and across the industry, through R&D, through universities, with regulators, with mining companies, with supplier organisations, with consulting companies, but solve those problems. And it just raises, I think, another question around, as an industry, should we be working towards some worldwide sort of repository of knowledge, so that we don't have to keep reinventing the wheel? I know that there's some repositories, sometimes localised provinces, localised countries, but again, we are a single industry, and we work worldwide. We break down country borders. So how do we create that ability to tap into the knowledge of the industry, no matter where you are in the world or in the industry? And I think that becomes increasingly important as we have people in the industry retiring, which, as I spoke about earlier, there's significant retirement rates in our industry as we have new people coming into our industry. But even as we have people working more remotely, so rather than teams of 10 people, there may only be 1 or 2 people now working remotely. How do we enable those people to have the knowledge of the 10, yet still be in the work situation that they're in at the moment? And finally, I think that all of this leads to, as an industry, if we want to increase the rate of change of our industry, if we want to solve these fundamental problems, and we've got the technology in order to be able to do that, we know that the speed at which we can implement, and especially enable our teams and our people to implement, the way in which we work collaboratively and solve problems across the silos, and we use especially data and visualization to do that. If we focus in, if we distill all of that down and we say, well, what are the 3 fundamental things that we need to be absolutely focused on as an industry? It's around, how do we, for these problems that we've identified, how do we make sure that the solutions that we're looking at are feasible? And I think, as I said, the great thing about feasibility is there are so many technologies being developed outside of our industry that we can bring directly into the industry, adopt and adapt a little bit to bring on the best of our industry as well, and the things that we have learned over the many years. But we focus to make sure that it's technically feasible. But then the 2 most important parts is it viable? What's the business case? How do we articulate that business case and don't bias either way? Again, I've seen business cases that greatly inflate the benefit of implementations of change, and I've also seen fantastic solutions be completely destroyed by an exceptionally negative view to the business case. But how are we clear around the viability, the fees of the business case, and the focus on the business case? But then the 3rd point that we often forget, and I think the one that's most important, is how do we make these changes desirable? How do we make the adoption of these new behaviours, how do we make these new technologies that enable the value to flow, how do we make those desirable to the people that are going to be using them? And again, I think some of these new technologies have come in leaps and bounds because they use characteristics of technology that we use every day in our home environments that we find alluring. We can learn from humanistic design in other industries and bring that directly into the mining industry. And frankly, we can work with our own teams, give them choice, give them a voice to drive these technologies and its implementation significantly faster, and therefore reap those benefits and fundamentally change our industry, making it significantly more sustainable as we go forward, faster than we've ever done before. Thank you.
Well, thanks very much, Michelle. That was really genuinely very fascinating and a great insight into the kind of the future we could be expecting. We have got a question online already, but also, Rick and Neville, if you have anything you wanted to contribute from here as well, please do. The first question we have here, Michelle, you might be able to see these questions, so it might be easy for you to read, but for the benefit of the audience, I'll read it out.
Stop the share. Yep.
So it's just in relation to the coherence and continuity of data across a mine site, which I think we all know is a really kind of big area. But the question is, do you know of any functional mine site at the moment that actually has successfully managed to integrate data across the different divisions? So you talk about silos. Do we actually see any of that data transfer across the divisions such as exploration, production, geomet, blasting, shovel, trucking, crushing, milling, recovery, environmental indicators? There's such a big, vast area to do that. Is it attainable, or is it happening?
Yeah, so look, I haven't seen it fully integrated in the mining industry yet. And I think, this is one of our challenges in terms of how we still think of ourselves somewhat siloed. But I'm starting to see within some of those chunks some vast improvements. So I think, if we just look even at exploration and the various stages of exploration, and the fact that, there's significantly more digitized information right at the front end, which then obviously allows, that integration, starting to see that very much. We're starting to see integrated examples between geology, mine planning, and finance. And that strategic mine planning and optimization of strategic mine planning, for example. Unfortunately, the process plant is still a little bit of a poor cousin, and I think one of the great leap forwards we could make is wedge that in, and also maybe think about how we go about planning. Should the process plant be a pull system? So we plan to maximise, and this is mentally for us, but we plan to maximise recovery and obviously throughput and ultimately the gold that we produce, or the copper we produce for a given economic output. Or do we see it as a reciprocal and we optimise the mine and we throw stuff at the processing plant, which is sort of our planning paradigm at the moment. So I think there's still some work to go in engaging with those. We're just starting to now talk to organisations and especially about looking at how the closure process works, and really trying to integrate closure in with mine planning and mine execution, but mine execution is still sort of being seen as a little separate from mine planning or some of those sort of processes. So we're starting to see signs, but we certainly haven't yet seen the integration in the same way as you see in other industries. And I think that's our next step and our next challenge. Oil and gas, for example, much more integrated, even nuclear power, all the way from design, build, operate, and closure of a nuclear facility. They use a digital twin that moves in time with them. So we see much more integration of data. So there's certainly the technology there, and there's certainly increasingly the interest. So these conversations are starting to be had. I think some more work yet to actually see examples of the complete value chain, but some great examples of mining companies that have done some aspect of that.
Just on a related point, I guess one of the things that I was keen to know is, what do you see as the major impediments to technology uptake? Because again, a lot of people, and we've had this comment internally at JK that mining innovation has been sort of around for a long time, but it hasn't really been adopted. Is it a generational issue? Is it a risk factor? What's the access to majors, to mid-tier, and to juniors? Are we going to kind of marginalise technology availability to certain demographics of mining companies as well?
Yeah, look, I think there's several answers to that. I think part of it is what I was talking about before. One of the things I know, I've talked to a lot of the startups that I work with about, or even in my own organisation, as technology providers, we don't always really talk to the customer, understand the problem they're trying to solve, and understand the value of that problem, and then lead with a business case that the technology happens to enable. Often we talk about the technology up front, and we're very passionate and excited about that technology, but then it becomes very confusing for the customer to really understand, you know, how is that technology going to help them or not help them. So I think that that's only part of it. I think there is a bit of a generational issue. You know, I know there's, I personally had challenges, you know, trying to convince people that that we need to do things differently. And that's all the way from a board through to, you know, sometimes people on the floor, that the change is needed. And I think part of that is that we have a misconception that no change is not risky. And so, you know, often when we go to investment committees, if, you know, this is more significant change, you know, the base case is stay as we are. And we sort of apply this no risk to that. Yet, you know, I think more and more we're starting to see that there is actual risk. You know, so let's just take diesel, for example, in our haul trucks. That is not a strategy without risk. You know, you've got to at least contemplate going forward that for some organisations, that may mean that they will lose potential investors. And therefore, you know, that has risk in terms of your access to capital markets, etc. I think to your point about will there be differentiators between, you know, juniors, the medium-sized and the majors. You know, I think as technology, all technologies follow Moore's law, roughly speaking. So technologies will come down in price the more that the industry engages in the use of that technology. And the other thing we do need to think about as an industry is we're relatively small. We see ourselves as quite a big industry, but from a consumer perspective, and, you know, as now a provider of technology, I know we have to go across mining and construction and, you know, biomed and other industries so that we can get the scale to drive the prices down, so that, you know, we're constantly meeting, you know, the expectations of our customers as well. So, you know, I think one of the things that as an industry that can happen is that the larger organisations can certainly spearhead the technologies, especially where they have potentially greater margins that allow them to use some of that margin. That gives them obviously a competitive advantage, especially if they can then implement those technologies rapidly across their business and not just do sort of spot implementations. And then, you know, pave the way as prices come down for others to use those technologies. Though, you know, others have advantages. You know, what I've seen in the medium-sized companies is much more flexibility, much more opportunity to move nimbly. But then the value case has to be really good and really focused on what drives value for them. And similarly for the juniors, you know, I was talking to, again, a company that I do some work with that I think are doing a great job looking at the different computer-aided geostatistics and geometrics, etc. You know, what I was talking to them about is their value proposition for a very junior mining company is, you know, how do they help them create more out of the ore body and what they've found, because the monetization point for juniors is to, you know, obviously get a better share price or potentially be bought by another mining company. So you've got to understand, well, what is that company's, how are they going to make money out of this change? And once you understand that, then, you know, you can really make sure that your technology is applicable. I mean, we shouldn't be trying to sell things to people that it isn't going to add value to. But also it's how do you phrase that business case, and therefore how do you create a model that makes it enticing for them to buy that product and therefore make those changes. So, you know, I think that then I think the other thing that does potentially slow our rate of change, and there's some validity in this, is you know, it's much harder to change, especially because we are sometimes integrated of systems in systems. Once you've established the mine, it's always much easier to make all of these fundamental changes at project stage. There's some concern sometimes from boards, and maybe this is a generational issue, to take on technology risk at that early project stage. So sometimes we miss out on some of those improvements. Again, I think if we had a good digital twin where we could actually demonstrate to boards that in the virtual world we have tested and tried these changes, you know, just like I explained with the aeroplane. We've flown it for 1 million man hours, we've run it for 1 million production hours, and be able to demonstrate in a virtual world that we have genuinely modelled this and that it is going to be an advantage, that plunges the risk down. And this whole conversation around technical risk doesn't disappear, but at least you've got some data and you've got an experience you can allow board members to go through with you, you know, especially if you can do it in 3 dimensions, as I said, take them into that experience. Because once you've built it, you know, even something like battery electric vehicles isn't just it's not like I'm just going to use a new engine and so I'm just going to replace one vehicle with the other. You've got to have the charging process, you've got to get the reticulation of the energy. You have to think about what you do about the fact that you now have diesel underground. How do we take that out? You know, how do we maintain them? It's still doable, absolutely, but we have to think about those changes, and therefore the benefit to the change is less, but still significant. But you have to overcome this, but we've always done it that way. So there's this extra hurdle to overcome, you know, once you've got into production. And so that does slow things down. Again, I would argue that a virtual twin, to allow people to see what those changes actually are going to look like before you commit. You can make changes in the virtual world, optimize it before you even try in the physical world, will speed up that rate of change all through the life cycle. And it's much easier to convince communities. And then, of course, there's the government issue, the legislative issue. You know, is our permit set on, you know, what we've already told the government we're going to do in this mine? Again, if you've got a virtual twin, you can show to the government, this is what I'm going to do. It's much easier for them to then make a decision about that faster. So, you know, I think there's many answers to that, but I think it's good solutions as well.
Excellent. Thank you for that. Just a couple more questions from our online people. There's a question from Scott Dunbar. I guess this might be hinting towards some of the work you might do within the circular economy, but can you think of any changes or innovations in the mining business model that can encourage more public participation in the metal and materials supply chain?
Yeah, that's a really good question. So there are a couple of startups that are doing really interesting things in terms of, you know, what we might consider to be urban mining. So, you know, there's one startup that was horrified by the amount of environmental pollution being created by the recycling of computers and phones to extract gold and copper, especially. And so they have developed a business model where they have a centralised sort of processing facility. Again, it's not a particularly expensive one, but a centralised processing facility where communities bring effectively ore, so waste, to that facility. They get paid, so it's a tolling sort of type process, and then they produce gold and copper, and they're able to do that quite profitably. So I think, you know, that's one way to engage communities, and you know, you can imagine that could be done, especially in some communities where you may be looking for employment, though, you know, there's issue about how you ship, obviously, that waste there. So, you know, they sort of need to be close to a waste source. So there's certainly models like that. There's certainly a model coming from Canada, which is really looking at community ownership. This is more of the mine itself, but you know, community owning the mine, and then the mining company being the integrator of skills in order to extract that wealth, or to you know, to exploit that mineral resource. I'm just trying to think about down the recycling sort of end. or the circular economy and how they bring things back into it. I mean, there is, again, some interesting work going on in a couple of organisations to do with blockchain, just trying to track. So what they're trying to track actually is the black matter from batteries. As we sort of want to have EVs and people sort of start changing out their EVs. Some of the early ones are now starting to, both batteries and cars starting to come up for sort of renewals and things. How do they track that through to make sure that each battery is actually accounted for and doesn't get lost in the quagmire of sort of black matter? And I know they've got some communities that are involved in that sort of recycling sort of process. But I think one of the important points that's sort of raised by that is, yes, we need more business models around how do we do urban mining? How do we, bring some of that circularity into our economy and our communities. The other one, though, is how do we think about, again, the modification of our own behaviours, of the citizens' behaviours, to help that process, around, do we bring our phones back for recycling? Do we bring our batteries back for recycling? Do we, something as simple, especially in Australia, separate out glass from plastics from poopy nappies, which, seems to be a struggle for us. But, so there's also some community behaviours that we're starting to see some collaboration around some NGOs around modification of community behaviours, therefore engaging them in the circular economy.
Just before we put our last question, Rick, if you're Rick had a question he was going to ask. He was going to paraphrase it in with a comment that Fernando had commented. So I was hand over to Rick.
Yeah, I was. Thanks, Nathan. I was just going to I had written down a question that had some similarities to one of the ones that appeared online, so I was going to try and paraphrase them together. I mean, lots of people agree that dealing with, reducing the amount of waste we mine and store and all that sort of thing is vitally important. But I think the point that was made, particularly by the person online, is that in order to do that, it implies that you're able to sense a whole series of rock properties at a really high resolution, because otherwise what you're doing is having automated trucks and automated drills and all the other automated stuff going around and mining an incorrect model, or a model that's based on very widely spaced information. And so the change that needs to get done is to incorporate all that sensing into a very quickly developed high resolution model that allows fast decisions to be made that maximize value in the sort of various sort of time frames. And we're not, it doesn't feel like we're there yet, although it's an important sort of thing to aspire to. Meanwhile, every year we're mining more and more waste, as we keep talking about how important it is to mine less. And so my question is really, how long do you think it's going to take for us to redress that balance and start mining less waste and start crossing that technological bridge that will allow us to incorporate all that high resolution data we're able to collect, but not really yet able to interpret at the speed we need to?
Absolutely. So I think what you're saying is absolutely right, that those four fundamental problems starts with geological ore body intelligence and being able to know our ore bodies down to the last gram. I mean, if I could wave my magic wand and gift the mining industry something, it would be that. Because even if we just knew that, even with our current processes, we would be significantly better. And then you can automate, and then you could take people out, and you can, and not take people out of the face, have people doing other activities. You can then precisely extract, just take out the things we want. So I absolutely agree with that. I absolutely believe there needs to be more investment and focus on that geological ore body intelligence. We spent a fair bit of time as an industry, not enough yet, but investing time and energy in automation. It's starting to be electrification, precision extraction. I think there's still some more we could do on the extraction side of things, especially when it comes to in situ leaching. But where I think we can get massive benefits, and I liken this to the car industry's focus on its customer and understanding the weird intricacies that are us as human beings, to a much finer level of detail. We absolutely need to focus in on that. And I'm starting to see, I think, some positive signs. There's some great organisations that they're looking at sensor technology, looking at speeding up the laboratory processes and how we understand certain characteristics about our machines, our ore bodies. There are some great organisations looking at how does geostatistics fundamentally change now that we are demonstrably able to do things with computers that we've never been able to do before. And I think there's an interesting little conundrum there, because I know, you know, some geologists are sort of disagreeing around whether that should or shouldn't be something that we do, but I think it is, you know, part of the process. And then of course, you know, we've obviously got to then go back into JORC and NE 340-101 and those sorts of things, and make sure that you know, our legislation keeps up with the technology advancements. But you know, I'm seeing a lot of focus. I would like to see a lot more focus on that end, especially because some of the other things are already in train. You know, robots that can you know, take out very narrow veins, etc. That's starting to come. So you know, I think we should see a significant shift, I would say, in the next 5 to 10 years in our ability to do that. And, you know, as we start using even more quantum computing, I think our ability to have that computational power potentially that's needed also increases, which I think is important.